Hey there, and welcome to exercise number 73. In this one, we're also going to do an exercise about trees, and it's going to be similar to the previous one, but instead of a BFS traversal, we're going to do a DFS one, so it's going to be depth first. Now, the input is the same as before, right? We have an object describing the root node of a tree graph, and it has a value, a left property, and a right property, right? The value is a number. Left is a reference to the left node if it exists, but this is optional, so it's undefined otherwise, and right is a reference to the right node, which again is optional. The function should return an array of numbers corresponding to the values of the tree in DFS order, and we're going to see immediately what this looks like. Now, I also added a small note saying that the left children should be visited before the right ones. Below we have an example, but it's the same tree as in the previous exercise. You can see here value 1, it has a left node and a right node and so on. But again, this is hard to understand as a human. Like, I'm looking at this and it's not easy for me to visualize the tree. So I created this graph in Excalibur, and it's the exact same tree as in the previous exercise. But the DFS search is different. The BFS one we talked before was done level by level, but this one is going deep. So we're going to start from 1. This is how it works. We start from a root node, and then we're going to go to the left. And again, why left? Because in this case, I said, let's visit the left ones before the right ones. But there's also, you can do a valid DFS search by going to the right node. That's fine. But in this case, we're going to go to the left. So we start from the root, and then we go to the left. And then we keep going until we reach a leaf. So we get 1, 2, 4, 8. And let's write them here. So 1, 2, 4, 8. Now that we reached 8 and there's no left to go to, we check, hey, is there a right? No, there's nothing. Okay, then we go back a level to 4 and we say, okay, we went to the left side. Now, is there something to the right? Yeah, we have 9. So we visit it. Now, again, 9 is a leaf. There's no left, there's no right. So we go back 4. 4 has no more children. We go back another level to 2. We visited the left side, now the right. So that's 5. 5 again is a leaf, so we go back to 2. We finished with 2 because we visited all those nodes. We go back to 1, and then from here we visited all of this, and what's left for us is to go to the right. So we're going to go 3, and we're going to put 3, and then we're going to keep going left, right? The same as before, but from 3. So we're going to say 3, 6, 10. Now we reached 10. This is the end. Let's go back a level to 6, and we see there's a node on the right. So we reach 11. Now this is also a leaf. So we go back to 6, nothing to go to, back to 3. And now we have just one option to 7. So 7 is going to be the last one. So as you can see, this one is using like a concept called backtracking. I mean, we're not going to implement backtracking. There's a simpler way to implement it. But in this case, you can see you're going down a path and then you're returning and then going back down and then going back up again and so on and so on. So let's see if this is correct. So we have, this is the output we got. So 1, 2, 4, 8, 9, and so on. And if we look here at the expected output, we can see it's the same. 1, 2, 4, 8, 9, 5, 3, 6, 10, 11, 7. Yeah, so it's exactly the same one as here. Now, if you want to solve this exercise for yourself, which I highly encourage you to do, then click on the link in the description. If not, keep watching and we're going to solve it together. Now I'm going to go here into the right side and I'm going to start similarly as in the previous exercise. So let's just create an array values in order. It's going to be an empty array and we're going to return it at the end. Values in order. And I'm going to create another one, nodes to traverse. And we're going to start from the root again. And here's where the difference will come. I mean, we're still going to have a while, right? So while we have nodes to traverse, we're going to do something. Now, the current node that we want to traverse is not going to be the one at position 0, but the last one. And we're going to add elements to the end and get them from the end. So if in the previous one, we were reading from the beginning and adding to the end like a queue, in this one, we're adding to the top. So it's like a stack. So I'm going to say const current node is nodes to traverse dot pop. So this one gives me the last element, but also removes it. We're going to do similarly if current node dot values in order dot push current node dot value, right? So this is the order of the values. And then we're also going to do an if here. current node dot left is different than undefined. And we're going to need to do one for the right as well. But now the question is in which order we need to do it. So I said we're going to add elements to the end. And why to the end? Let's just do a little bit of, let's say, console log here. I mean, not console log, I mean comments. So I start from node 1 and then I visit 1, which has 2 children, right? 2 and 3, right here. Now, which way I want to go? So I'm going to need to put them to the nodes to traverse. And if I'm going to do nodes to traverse is going to be 2, 3. And then I'm going to take it from the beginning. Then I'm going to be like, okay, 2 has 4 and 5, but 4 is going to need to be the next first one if I'm going to take it from the beginning. So it's going to be different to add elements to the beginning always. And this way, I'm going to add them to the end, but we're going to need to add them in this order. So first the right one. And I think I may have made the things even more complicated than they are. So let's actually do it here, because I want you to really understand it, not just the solution. So I'm going to do here, let's do nodes to traverse. And we're going to do values, right? So initially this is 1 and values is an empty array, right? So this is the initial one. Then I'm going to iterate through, I'm going to visit number 1. So it's going to be here 1. And this one is going to be, it's going to be empty because I remove it, but now I need to add 2 and 3. So my idea is to add 3 first, the right one, and then 2. And if I do this, right, I can always take the last element, because now I can go here and be like, okay, now I'm going to traverse this. I'm going to remove 2 from here. I'm going to put 2 here. And I'm going to take the children of 2, and I'm going to take the same rule, right first and then left. So I'm going to take 5 and then 4. This way, when I pop it, the left one is going to be first, right? Because at the next iteration, let's go here again, I'm going to do, okay, I'm going to take the last one, 4, remove it from here, and I'm going to take 9 and 8. So right first. And again, I'm putting the right first because I want the left to be when visiting first. So I put the right, then the left is the last. When I pop it, I get the left one. So I hope that makes sense. Now let's go back to our code and let's test it before I submit it. So I'm gonna do console log dfsTraversal of this one. And oh yeah, I didn't do here nodes to traverse that push current node. Of course, I need to do it. Nodes to traverse that push current node dot right, actually current node dot right dot left, sorry. And we get this array 1 2 4 8 9, and it ends in 7, so it looks legit. Now let me just remove some comments from here and let's test our solution, and voila, it works. Cheers and see you in the next one.